Hello, everybody. Welcome to the very first episode of Precision Perspectives. I am your host, Jordan Yates, the marketing engineer at Knowles Precision Devices. Today, I'm really excited because our first guest is Peter Matthews, the director of technical marketing here at Knowles as well. So, Peter, say hello to everybody.
Hello, everybody.
So, guys, I'm super excited about today's episode because this is going to be the foundational episode of the rest of this podcast, and it's going to be on the topic of capacitors. So, I know what you may be thinking at first. What is there to say about capacitors? Well, don't worry. We will expand it in ways that you weren't possibly thinking of before, and we'll kind of explore the fundamental, question: what are capacitors? Peter will give us a comprehensive understanding, tell us a little bit more about their basic principles and why they're integral to the world of electronics. So, whether you are interested in learning about capacitors or the applications they're in, this is the podcast for you. So, Peter, how are you feeling? Are you ready to talk about capacitors?
I'm so ready.
There's nothing you're more ready for right now. So,
Absolutely. Yeah, let's go.
I'm going to kick us off with the first segment, which we like to call Say It Plainly. Now, I have to admit, I have stolen this wording from Peter because Peter's always telling me to say it plainly, and I just like that. So that's our first segment. And it's going to be the basics of capacitors. So, Peter, for our listeners who are new to electronics or just want a refresher, can you explain in simple terms what capacitors are and how they work?
So, um, so there's a quick answer, which is capacitors are things that have capacitance. Um, but that's not terribly helpful. So, um, capacitance is it's an electrical property, um, and it describes the ability of something to store charge, right? And so people are probably familiar with the idea of, negative electrons and then positive, they're not electrons, they're the absence of electrons, but that's the idea of charge. So capacitance is how much charge can you store?
Mm-hmm.
Um, Capacitors store energy. They store energy in an electric field. Um, and one of the ways you can make an electric field is you can get two opposite charges and you can hold them apart, right? So you can hold your negative and you can hold your positive, and you hold them apart, and a field forms between them. Um, so an example is if you get two metal plates, right? You hold them very close together because fields don't travel very far. But if you hold them very close together, um, and you have some positive charges on one side and some negative charges on the other, a field builds up, and you get what we call a voltage.
Mm-hmm.
Now, voltage it's the sort of physics term for it is potential difference. It's the it's the ability to do something, right? It's something being stored up. Um, Now, so you've got these charges, and some of them are lined up on this side, and some of them are lined up on that side. And then the question is how do you actually get them there, right? Well, you get them there by applying a voltage, right? So if you hooked up a battery to either side of these plates that are separated by an insulator, and that's the important thing, the
Mm-hmm.
charges can't actually travel. They're separated, and there's a crowd of positives on this side, and there's a crowd of negatives on this side, and they really want to mingle, but they can't. They're separated by a gap.
Mm-hmm.
And how much of that is capacitance? And a capacitor is a thing that has capacitance. Now, what you can do, um, so you've got your voltage and you've got your charge, and the amount of charge is equal to the voltage times something called the capacitance, right? And we usually measure that in units called farads, and the more farads, the more charge we can get for a given voltage. And what you can do is you can actually increase that property called capacitance um, by using a dielectric material. You
Mm-hmm.
can kind of mess with the field, and you can get more charge for less voltage or vice versa. Um, so capacitors are things that have capacitance. Um, capacitance is the ability to store this charge. That's
Okay.
basically it. Um, and that's what they are. That's what they do. They the main thing is to remember that they store energy in an electric field.
Okay. If
So how?
somebody is so like maybe I had exposure, early in physics of like C, is in the equation somewhere, your capacitance. But
Yep,
if
yep, yep.
somebody's maybe more mechanical background, because I know there's a lot
Yeah,
of
yeah, yeah,
shifting in
yeah.
the industries,
Yep,
because like I came from a mechanical background, petroleum, and then I ended up in manufacturing. All of a sudden, I'm worrying about capacitors. Could you give a like sort of everyday analogy of something that maybe you don't have to be like an engineer who knows electrons or something like that, but an
right,
analogy to what
right.
a capacitor is
So,
or what
so
it
pretty
does?
much, most people, I won't go as far as to say everybody, but most people know what a spring is,
Mm-hmm.
right? You pull a spring and you let it go and it snaps back, or an elastic band, like a spring or a rubber band. Um, a capacitor is very like a spring, and how stiff that spring is, how springy it is the capacitance, right? And so you can imagine this really heavy duty, like industrial spring that, I don't know, you could hang a car off or something. That's like a massive capacitor. And then you got these little weedy ones that you might find in a kid's toy, and that's like a little capacitor. And then the other cool thing you can do with a spring is you can hang a weight off it, and it'll bounce up and down.
Mm,
And now the weight is something we call an inductor, and the spring is a capacitor, and you've made an oscillator because it's bouncing up and down, right? But when you look at the equations for springs and you look at the equations for capacitors, they kind of line up, right?
interesting.
So there's this notion of stiffness in a string, right? How stretchy is it?
Yeah.
That's like capacitance.
The oscillator analogy is honestly helpful for me because I see a lot of oscillators in my research, so I kind of like that for me personally. Okay, so that was pretty helpful in my point of view as to understanding kind of, point blank what a capacitor is. I like the analogy of the spring. I think that's pretty cool. If you guys have any cool analogies that you want to add in, you guys can always write in. My email's in the description. So I love hearing different creative ways to understand complicated things. So feel free to write into us, tell us what you think would be a cool analogy for a capacitor. But for now, we're going to move on to the next segment, which is called Who Should Care? So, Peter, I want to know like what the relevance is of this topic of capacitors to different audiences. So, we know they're
Yeah.
fundamental in electronics, but why should people from various backgrounds, from students to engineers, care about understanding something as small as a capacitor?
Um, I mean, and you mentioned it, right? That they are fundamental to electronics. They're everywhere, and you can't make what I would call a useful circuit. You can't make a useful circuit go without a capacitor, right? And one of the things about a capacitor is it's it's like a resistor, right? So a resistor, you can almost think of like, uh, in our mechanical analogy, you can think of it as friction, slowing
Mm-hmm.
things down a bit, right? Well, a capacitor does that, but at certain frequencies, right? Um, and if it, most useful circuits in the world have voltages that change over time,
Mm-hmm.
right? So whether it's the audio signal, right, that's being processed for this podcast, right, somewhere between my microphone and the DSP and the memory, there's a whole bunch of capacitors helping that changing voltage do what it's supposed to do, right? Most useful circuits in the world have changing voltages over time. You can't control changing voltages over time without some capacitors hanging around and helping. So they're everywhere there's a useful circuit, and we are surrounded by useful circuits nowadays. Yeah.
So maybe somebody's like, okay, I get they're cool, but I'm not gonna dedicate my life to capacitors like you guys are. Like, I don't want to work for a capacitor company. Like,
That's
that's
fair
so
enough,
niche,
right?
right?
Um,
So maybe they think that, but like, if they want to be really cool and say work for like a big car manufacturer for electric vehicles and they want to
Right.
design aerospace aircrafts, things, all of that nature, like
Yeah.
wouldn't they still need to understand how capacitors work?
Absolutely. Right. So capacitors store energy. Right. What are some situations where you want to access a bunch of energy quickly? Um, you know, there are there are medical situations where you need a bunch of energy quickly, like defibrillators,
Mm-hmm.
right? You see in like, um, well, I Grey's Anatomy, right? And it's they zap the person. There's a capacitor helping provide that zap, right? Anywhere you need to zap, you got a capacitor helping. Um, so if you're interested in medical technology that saves lives, capacitors help. There's I don't know, you think about the film Top Gun, right? And they're trying to land on the aircraft carrier, and they're doing that at night, and there's these bright lights that are flashing. Again, there's a pretty big zap there, and that's a huge capacitor doing that, right?
Mm-hmm.
Um, and then there's also, like we talked about, like controlling changing signals. So if you're interested in communications, if you're interested in sending signals over the airwaves, you're gonna you're gonna use signals that are changing over time. I mean, we fiddle with the frequencies and the phase of these signals to encode information. We live in what people call the information age. Um, you need capacitors to do that well. And so
Mm-hmm.
even if somebody doesn't think capacitors are the best thing ever, and they don't dedicate their lives to the design of capacitors, if they're working on or with a circuit, knowing what capacitors do is kind of important.
Yeah, no, I definitely agree. And, I would say I'm biased, but even in my hours of the day outside of being paid to care about capacitors, I am often just pointing things out around me, being like, yeah, you know how many capacitors are in that electric vehicle? Do you know like
Right.
what it took
Right.
capacitor technology wise to make that electric vehicle charging station? Like to me, once you kind of understand where they are, it becomes a fun game of just telling everybody, do you know that there's capacitors in here? And they're like, what is a capacitor? Now I have an episode to refer them to, thank God. But that you kind of beat me to our next segment, which is called In the Real World, where
Ah,
I wanted you to give me real world examples, but luckily, don't worry, Peter, we still get to expand here because I know you were so worried. You touched on examples. I kind of want like a full blown, like piece by piece, where I can find capacitors in a certain example. So maybe it's a UAV. I know you'll love those. Maybe it's like an infrastructure example, for instance, like solar power to all the way to EV charging and all the
yeah.
stages capacitors are in. I'll let you choose.
So you want lots of them, or do you just want one good example?
I want whatever feels best to you.
Ooh. So, okay. Um, there's. I'm trying to think of something that everybody has experienced,
Mm-hmm.
and most of us have some experience of Netflix, right?
So
Streaming
much.
services.
So much.
Too much, right? And over Christmas, it sort of ramps up. But so, streaming services, and it's like, okay, cool. So that content, those files are stored in the cloud, the magical cloud, and the cloud is made up of data centers, right? Racks and racks and racks of basically big computers with lots of memory that know where to send the information and when.
Mm-hmm.
Um, so if you just take that one example of watching Netflix, capacitors are involved. Well, they're in your television, right? They're fairly basic, but they're in the television. And then whether you have fiber or cable, they're in the so to boost a signal, you have a thing called an amplifier, and there's a bunch of amplifiers in the chain. And making an amplifier work correctly requires a ton of different kinds of capacitors, right? So if you take the cable example, Um, there's hybrid fiber coax. There's a network of cable TV. There's a network of cable that this data is being sent down, right? And there's a bunch of capacitors involved in making the signal strong enough so that your Netflix doesn't buffer and frustrate you. Um, and then this stuff is in the cloud, right? And you've got these data centers, and these data centers use enormous amounts of power. You've got
Mm-hmm.
lots and lots and lots and lots and lots and lots of computers. And so one of the things they do is they try and maximize efficiency. And one of the ways you maximize efficiency is you improve the circuit. And one of the ways you improve the circuit is you buy really good capacitors from companies like ours. Um,
Subtle plug.
subtle plug. And then the other thing is, oh no, what happens if the power goes out, right? And so these intermittent spikes in power. So a capacitor, because it can hold on to energy and then let it go, kind of like the spring, right? We can mess with how quickly that happens, we being the circuit designers, right? And so if you had a spike or a dropout of power in your data center, if you've got a friendly capacitor somewhere in the circuit, it's okay. I've got some energy I'm hanging on to, and the server keeps going, and the people at home keep watching Netflix, and they're happy. So Netflix is brought to you by capacitors. I mean, amongst other things, but
Yeah.
you know.
Yeah,
So
no, it's crazy because like I feel as somebody who's only been in this industry a few years that like if you would have told this to me a couple years ago, it would have kind of blown my mind because when I hear the cloud, I'm not thinking racks and racks of servers and data. And maybe that's because I'm so literal. I'm just thinking like magically in the air, there's my Netflix.
right.
So I think that although this is something that we are so desensitized to as being a part of this industry, it's important to actually say it so people who aren't as desensitized and experienced as we are can hear it for the first time somewhere because I think it is really cool how it's all connected and I think Netflix was a great example. I always go for electric vehicles because I'm lazy and that's the easiest example, so I appreciate
Well,
that you stepped
e-
out and went into Netflix.
EVs are cool, right? So, what is it? They say there's about 10,000 capacitors in an electric vehicle. 10,000 of these
That's
little
a lot.
widgets, right? Bag Bagfuls of them, because they were doing all sorts of jobs in making the car go. Um, but yeah, we love our technology, we love software, we love apps, but all of that has to run on hardware, and hardware doesn't function without capacitors. Just can't do it.
I, it's insane to think about that because we do live in such a software world. I forget that it does have to live somewhere
Yeah,
before
it's
going
to have a
into these
home.
magical clouds.
Yeah,
Yeah.
yeah,
So now like we kind of took it out from a bird's eye view of applications because to me that's important so people can locate sort of and visualize where these capacitors are, but can we get a little deeper into maybe the weeds of capacitors itself? And that's our next segment, getting into the weeds. And I want to kick that off with maybe some technology trends of like there's different kinds of capacitors, they've evolved over
yeah.
time. Like what capacitors, like what are the main types of capacitors? Let's start there before I ask you too many questions at once. And what
Yeah.
kind does Knowles do?
Right. So, and that's a good starting point, right? So,
Mm-hmm.
at the very beginning, we had our metal plates separated by an insulator, and then we were going to use a thing called a dielectric to mess with how strong that field was, right? How much charge we could get. So, one of the ways of understanding the different technologies is to look at the dielectrics, the material that's being used as kind of an insulator.
Mm-hmm.
Um, it is an insulator, but it has certain properties, right? So you can have a special kind of ceramic, um, and that has certain chemicals in it, and that has certain dielectric properties, and that allows you to make capacitors in a certain way. And we say, excuse me, ceramic capacitors.
Mm-hmm.
Um, but you can also um, you can have basically metal foil and then a special plastic film
Mm-hmm.
and then some more metal foil. And now you've got what we call a film capacitor, right? Because that's the dielectric. So the theme is, what's the dielectric? There's always these metal plates.
Yeah.
Sometimes they're stacked on top of each other. Sometimes they're rolled around in a tube, but it's what's separating them, right?
Mm-hmm.
And then with aluminum capacitors, I think what they do is they actually allow the surface of the aluminum to oxidize, and that creates, in a controlled way, and that creates the dielectric. Um, I don't know as much about the latter too, because you asked which kind we make, and
Yeah.
historically we've been all about ceramics.
Mm-hmm.
It's one of the things the company does is we actually make our own ceramics from scratch, and we mix the chemicals and we make them how we need them to be. But we recently, the company just recently grew, um, and now we've acquired a company called Cornell Dubilier. No, Cornell Dubilier. Pronouncing it is always fun.
You have an
Uh,
accent, so you can say it wrong, and people would just be like, "It's his accent."
Cornell Dubilier. Cornell Dubilier. Um, I guess it's supposed to rhyme with chandelier. Um,
Okay.
but
Okay.
they're experts, right? So just like we Knowles, sort of legacy Knowles has been experts in ceramic material. They're experts at the aluminum and the film.
Mm-hmm.
Right? So now we do all three of the main types,
Yeah.
which is really cool, right? Because then the other way of understanding capacitors is, so we talked about the capacitance, the C, how much charge can I stuff in this thing? Um, Another important spec is the voltage, right? And so if you looked at capacitors and you said, what voltage can it work at before it explodes?
Yeah.
Um, and what capacitance? And you find that ceramics belong in a certain part of that map, and then film is kind of up here, and then aluminum is kind of down here. And they overlap, but there are like these different countries on the map now. So depending on what the customer's trying to do, right, there's going to be a likely candidate technology for the capacitance and the voltage they need to hit. Right? So if they're doing super high voltage and super high capacitance, it's probably going to be a film cap. And some of
Mm-hmm.
these film caps are big, um, like heavy to pick up. Um, and then you've got, but if you're just going straight up, so you've got sort of regular amount of capacitance, but really, really high voltage, then maybe it's more of a ceramic thing. And you say, well, why would I use ceramic? And you say, well, because you can make it smaller, right? So you can visit these different parts of the map, the land of capacitors,
Yeah.
and it depends on the situation as to what kind of technology you're going to need.
If you guys are watching on YouTube, I'll like pop the capacitor map up on the screen. That way you can kind of see what he's talking about. And then on the landing page, I will put it there as well, so you guys can kind of get a feel for it. But I think that's very true. There's so many different jobs for capacitors to do, and we won't even get into that today because we can go all day per job, per role, per kind. But I think the important part was to know that there are different kinds of capacitors within this section of the word capacitor. So I'm glad that we touched on that. I'm curious, like, is there any like fun parts of this capacitor? So I kind of want to get into our rapid fire round where you could share maybe a intriguing or lesser known fact about capacitors that will surprise our listeners. So take it, zoom out from technical, and now let's get into something fun. Not that that
Um,
wasn't super fun. I'm having a blast, by the way.
so, so the thing that pops into my head is that there's a certain dielectric that looks like caramel. Um, and there's a book called Open Circuits by a guy called Eric Schlepfer. I'm probably going to butcher his name, but what he does is he takes these really, really beautiful photographs of the guts of circuits, right? So we were talking about, technology needs a place to live, and it lives in hardware. And what he's done is he's actually cut these things open. And I'm going to get this wrong, but it's X7R, right? Jordan, you
Hmm.
would know better than
Yeah,
okay.
the caramel colored one for sure.
Yeah, XO&R looks like caramel. They look delicious. I don't advise trying to eat them, but they look really cool.
I
Um,
can't tell you guys how many emails I've gotten from Peter saying, "Look at these delicious capacitors." And anytime someone new joins the team, I'm just like, "Yeah, let me explain to you what a delicious capacitor is."
these ones are chewy. These ones are
Yeah,
chewy.
that looks good. I want some of those in my stocking. But I have a question. So the way that it just is clicking for me right now, I look at a lot of schematics every day of like, and guys, that's like an engineering drawing that takes the circuit and they draw it in a special way to show other engineers how to build it. Peter, you kept talking about the two metal plates and how they're far apart, and that's kind of the basis of capacitors. Is that why it's two lines on a schematic?
Yeah, it's
Oh
really
my God.
literal. It's so
Wow.
literal. They're just drawing what it is, right? And like we said, different technologies, right? You can stack them up, or you can interleave them, or you can fold them around. But yeah, in the drawing, which maybe you can pop up on the screen,
Yeah.
it's a really literal. It's a capacitor. It's what it. Yeah, it's probably the best one actually, because the resistor is like a wiggly line. So what does that mean?
Yeah.
Yeah,
Yeah, no, that's
capacitor.
funny. As you were saying that, I was like visualizing it. I'm like, hold on a second. And I'm sure I've had this epiphany so many times, but right now it feels really fresh and good. So I just wanted to confirm that that was the case because Peter has a very physicsy background. So I'm sure that just seems like something that you would actually definitively know. But Peter, we are getting to the end of our episode here and wrapping up. So before we sign off, I'm curious, is there anything else that you want to mention about capacitors? Any points you want to drive in before we let you go?
I would say that they're a fundamental building block, right? You can't make a good circuit without them. The world is made of good circuits, whether it's a ATM machine or a jet plane. Um, and yeah, they I guess when they're doing their job well, you don't notice. They're just there.
That's beautiful. I love that. Well, guys, a couple of times Peter did reference some communications and some other filtery type aspects. And so, if you want to get more into that, our next episode is going to be what are filters. It's going to feel similar to this, but we're going to kind of get into the other side of this topic and drill down there. So, I hope you guys enjoyed this very first episode of Precision Perspectives. And as always, I'm your host, Jordan Yates, and I will see you all next time. Bye bye.
See ya.